Hello students. So we will continue from the problem that we had discussed in the last video of convolution integral. So the question says if there is a signal x of t which is passed through a system h of t which are as given in the figure, find out the output y of t. Obviously we know that y of t has to be calculated using the convolution integral. And based on that, the equation here we have made a slight change. Instead of ht minus tau, we have written minus tau first and then plus t. And the first thing that we drew was x of tau and h of minus tau by considering that t is equal to 0, and that is what we are having here. So when we consider t is equal to 0, look at what is the value at t is equal to 0. That here, this is the value at t is equal to 0. Now if I am going to write t is equal to minus 1, that means I have to move whatever is the signal here, I have to move one step this side. Okay, why am I moving to the left side? Because already we know that since the time axis has been reversed, as you can see here, the time axis is already reversed. So if it is negative, we will move towards the left side. If it is positive values, we will move towards the right side. Now next thing that I always ask all the students to do is basically please draw the points where the signal is going to undergo a big change. So one is the point that is here, and here is the second point where the signal is going up and at the same time coming down. So these are the 2 points that change, and here similarly it is going to be this point and this point. So these 2 points I must remember, because based on that only the equations are going to be. That means, the first thing that we have to do is we have to shift this so far that the signal is basically just starting, or they are just meeting. So as you can see, at this point the signal x of tau and the signal h of minus tau. Now since I have shifted it here, it is minus tau minus 2. Okay, so now the signals are just meeting. So from here we will start. So before that, if I shift this signal further in the back, then all I am going to get is always, the value is always going to be 0, because the multiplication factor that we are calculating in this particular equation, that will automatically come out to be 0. So this is the point where we start. So I will write, first I will write for t less than or equal to minus 2. For t less than or equal to minus 2, y of t is integrating from minus infinity to infinity, x of tau h of minus tau plus t dt. This is going to be equal to integral of minus infinity to infinity 0. Why? Because the multiplication is always going to be 0. So that fact I have to take into consideration. So this is going to be equal to 0. So y of t is going to be equal to 0 for t less than or equal to minus 2. Next, I have to move this particular signal inside. So I will just, suppose I have moved it a bit inside. I have not completely taken it all the way along, but it is now slowly inside. So I have to draw a signal which is slowly inside. So let me draw that. So now you can see that the signal is slowly moving inside. So I have drawn these 2 lines. These 2 lines are the lines of, where the signal of x of tau is basically changing. Similarly, here the first part of the signal h of minus tau minus t is slowly entering. Now it is entering. You can see that if I am going to mark the 2 points, so this is one of the points where the signal is changing, this is the second point where the signal is changing, then you can see that the first point has already entered through the axis. And this movement we are showing it as t because we are not claiming that it is reaching here or it is reaching here or it is reaching, no, we are saying that it has entered. And we are going to write this time until and unless the back point enters. So how do we write that? How do we write that? We write that by saying for t, now look here, t greater than -2 but less than how much? This I am going to move inside. How much can I move inside? Okay, so if I am going to draw this signal, then you can see that the the front end of the pulse, okay, that I am going to write t. The back end will be based on the width t -2. So this t is not specified, but here I am going to write t. T is greater than -2, but it is less than how much? Until this back portion comes and meets the axis. So when will this back portion come and meet the axis? It will meet the axis when t is equal to 0. That means when this signal has reached almost 0. So up to 0, so less than equal to, so t greater than -2 and t less than or equal to 0, I am having this, and in that case y of t is going to be equal to, so let me write the equation, -infinity to infinity x of tau h of minus tau plus t d tau. This should be d tau. I have wrongly written here dt, it is d tau, sorry. Yeah, so that will be equal to how much? So if you would see the limit, if I am going to multiply this signal with this signal, obviously 2 and 2 are going to get multiplied, so I will get 4. Okay, I will get 4. But where is the signal going to be? It is going to start from this axis, and going to be up till this much time, that is t. So from 0, not 0, it is -2, it is at -2, isn't it? So from limit is going to change from -2 up to when t. So from 0 up till t, I am going to have the multiplication factor as 4. Why? Because basically if I am going to multiply this signal with this signal, what will I get? Let me draw that, just for you to understand. If I am going to multiply those two signals, I will get a signal that starts from here and exists basically from here up to here. So what is the time period? If you look at what is the time period here, the time period here it is -2, and what is the time period here? Here the time period is t. So it is going to exist from 2 to t with the height of 4 because it is getting multiplied. So this multiplication value is going to be integrated, so that into d tau. And we know that if we would integrate, we will get basically 4t with limit from -2 to t. Correct? In that case, I will get 4t then minus of 4 into -2, which is going to be -8. So -8, which will be basically +8. So y of t is going to be 4t plus 8. That is going to be the equation of y of t for the time period between 0 to -2. Okay. So next, again I have to draw for the next case. So let me draw the signal. So now as you can see in the tau axis, if I am going to now draw the signal, I will draw such that it has already entered the first axis. The back side has already entered the first axis, and then it is moving. The front end has basically moved and it has moved here. So why I am now taking this, because in between there are many stops, but I have already taken for t between 0 and -2. So now I have to take for a time which is t greater than 0. So I will write for t, let me give space, for t, sorry, for t greater than 0 but less than or equal to, until what time will this, this signal will go as such. See, when you are trying to multiply, both the what do you say, both the axes are there, and this multiplication will keep on going until the front side of this meets this axis, until the front side of this pulse meets the next axis. So based on that time will be when this axis is at what value, this axis is at +2. So until it meets +2 it will go. So I will write t less than or equal to 2. I will have y of t. So I will write this one here, it is 2, here it is 0, it is t, and this is t minus 2. So now if I am going to multiply the original signal x of tau with h of t minus tau, what will I get? See, I will get basically a signal. I'll just draw it. It will start from here and it will end here. Why? Because the signal other places it is going to be 0. So this time period is going to be t, and this is going to be t minus 2, and this height is going to be 4. So now if you would ask me what will be y of t, then I will say y of t, which is given by the equation minus infinity to infinity x of tau h of plus tau minus tau plus t h of minus tau plus t d tau, that will be basically having an integral. Now the limit is going to be from t minus 2 to t. So t minus 2 to t 4 d tau. From that we know that basically we will get 4 tau, sorry. Same is the case here also, it should be tau, sorry, with the limit t minus 2 to t, which basically we will get 4 t minus 4t minus 8, correct, which comes out to be plus 8. So between 0 and 2 the value is going to be 8. Then we move further until the front end basically goes and touches this and moves even beyond that. Since the equation is going to be h of minus t plus tau, minus tau plus t, so everywhere it is better for me to write it as plus t. Here obviously it is plus 2, but if I am going to write this as if I am going to write this as plus t, then also it is not an issue. We had written for the particular case of 2, so that is also not an issue. Maybe we can move the signal a bit back so that the signal is not exactly at minus 2. That is also okay. Anyway, so next I am going to take this signal until the front end breaches the next axis. So I will basically draw that the signal is such that the front end has broken apart, not apart, basically it has breached the first axis. See, always whenever I am drawing, I am always mindful of what is the width, so that I am able to write that always. If I am not able to write that, then it is going to be a problem for me to write the limits, so that I have to always take care. So this is t and this is t minus 2. and this will be tau. So now for the next time, which is for t greater than 2 but less than or equal to, when this back side will cut here. When will the back side cut this axis? The back side will cut the axis when t becomes close to 4. That is the time when the back side will cut the axis. We know that the axis is at 2. The axis is at 2. So if the width here is 2, then obviously the back side, if it has to come to 2, then the front side should come at 4. So with that in mind, what we will write is that it is to come up to 4, and then we will write y of t is equal to, so now I'm not going to write the equation again and again. Now you can see that if I'm going to multiply this with x of t, then basically I will start the signal at this point and the multiplication will end at particularly this point. Clear? And this value is what? This is t minus 2, whereas the upper will always be 2 where the axis is. So based on that, I will write the limit basically goes from t minus 2 up to 2, and within that time the value, the amplitude is going to be 2 into 2, 4, because here also the amplitude is 2. So 2 into 2 is going to be 4. So 4 d tau. Based on that, I will get 4 tau with limits at t minus 2 and 2. So based on that, basically I will get this is equal to, if I'm going to calculate, then 4 to 8 minus 4 into t plus 8. Plus 8 or minus 8, sorry, minus, just wait, we will go to 4 to 8 and minus of 4t, and then minus and minus becomes 16 minus 4t, correct? So this is the value for time period between 2 to 4. Now the last part will be when the last part moves out, because once the last part moves out, this is going to end. So I will draw that very quickly and that will end the problem. So if I am going to draw it, then obviously h of this thing will come here, and now the signal is going to be drawn such that the back side has also passed through the second axis, and then we can draw with a width of 2. Okay, so now this is at tau axis, this is at t, and this is at t minus 2, and we can directly say that the multiplication is obviously going to be 0. Even though the amplitude is 2, the multiplication of this one is going to be 0 with x of t, because now it has passed, these are the two axes within which x of t is there. So that is gone, means now the multiplication is going to be 0. So I will write for t greater than 4, y of t is going to be equal to 0, because the integration is going to be 0. So this has given me 4 equations. One is for this time, okay, another is, I'm going back, okay, another is for this time, then another is before that, that means between 2 and 0, then another one is between 0 and minus 2, and then the final one between, sorry, less than minus 2. And I will write for all these values, I will write the final equation. So if you remember, you can look into your notes. I am having from, y of t will have different values. One value is for t less than minus 2, okay, less than or equal to minus 2. At that time the value of y of t is 0. Okay, then we will have, let me write it like this. Okay, then we will have the second case. Let us look at the second case. So this was the first case. The second case is basically this one. So between this, the value is going to be 4t plus 8. So I will write that. So I will write t greater than minus 2 but less than 0. The value is going to be 4t plus 8. So 4t plus 8. Then we will look for the next value, which is basically from 0 to 2. So for t greater than 0 but less than or equal to 2, what is the condition? The condition is that you will get the answer as 8. So this is equal to 8. Then we go for the time period, next one which we have calculated, which is between 2 and 4. So I will write for value of t greater than 2 but less than or equal to 4, I will get the next equation. What is the next equation? 16 minus 4t. So I will get 16 minus 4t, and finally for t greater than 4, the values are going to be 0. Sometimes in certain textbooks these two are omitted out and they write just 0 elsewhere. So if you want to follow that, that is also okay, but this is what I do and this is more clear for me. So now with the help of this you can even draw, and since you already know how to draw the signals, we have seen it already, I will just draw the signal straight away and you can later try to draw it yourself and try to find out if we have drawn it correctly or not. So I will draw straight away y of t with respect to t. The signal is going to be 0, 0 up to minus 2, and then it's going to change. So then this is going to be 2, this is going to be 3, 4, like that, correct? So now I am going to draw the signal. So up till minus 2 it is going to be 0. From minus 2 it will go all the way up to, so if you put the value of t here, if you put the value of t is equal to minus 2, you can get in this equation the value is going to be 0. If you put the value of t is equal to minus 1, you can see that it is going to be 4. So based on that, if you would try to draw, basically you will see that up to 0 it reaches the value 8. So I'm going to draw it like this. It goes all the way up to 8. So it should be a straight line. Let me draw a straight line. And then after this, the signal basically goes from 0 up to 2. The value is maintained at 8. And then from 2, it goes all the way up to 4. Again, it goes down. It's a straight line. And then from there, it becomes 0. So this value I will write it as 8, and this is how the signal y of t is going to be for the case of the convolution between x of t and h of t. So go through this very carefully. What I want you to all remember is that whenever there are two signals, the first thing you should draw or you should do is, if there are suppose two signals, look where the signals are changing. So one of the point where the signals is changing is this, this and this. These are the time periods when the signal is changing. So if you would straight away draw the axis at these time periods, and then in the other cycle you can, or the other signal, you can basically find out where the signal is going to change, where the signal is going to change. So based on that, as you take the signal inside, where and all it should basically, the equation should be found out, that you can see. For example, here the signal is first, the leading edge is going to first cross the first axis. So there will be one equation for this position, the second equation for this position, the third equation for this position, the fourth equation, see, it is just touching both of this. So the fourth equation for this one, the fifth equation for this, the sixth equation will come here, then the seventh equation will basically be here, then the next equation will come here. So like that, the number of equations will be basically decided by where all the signals are basically changing, and based on that where all the equations have to be found out. So based on that, if we are actually calculating, we will be able to always calculate correctly the answer y of t. So thank you. Next class we will do one more problem to see and understand convolution integral much better. Thank you.